Welcome back to the Automation Podcast, the world's #1 industrial automation product and technology show. Thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. Now, if you're new to the show, my name is Shawn from Insights in Automation, and each week I invite a new vendor on the show to talk about products and technologies. And this week on the show, we have Craig Nelson from Siemens on to talk about their new servo drive, the S210. Craig, welcome back to the Automation Podcast. I'm really looking forward to learning about your new servo drives. But before we get into that, could you introduce yourself to our audience for those who may not have seen that last episode you were on?
Yeah, thanks, Shawn. It's great to be back. My name's Craig Nelson. I'm product manager for Siemens Motion Control, General Motion Group, and I manage a lot of the Sinamics S-type products or system type drives, if you want to call it. We also term those our discontinuous motion type applications as well. So, we have a very large, comprehensive portfolio of Sinamics converters. If we take a look at our low voltage converters, we will typically call them, a continuous portfolio, which is more of our general purpose VFD, and then we have our discontinuous portfolio, which is more of our system drive. And that continuous or discontinuous, a lot of times it's just like an application class. So if we take a look at a general purpose drive, a fan, a pump, a compressor, typically, you're going to change your frequency, you're going to change your speed with that VFD. But typically, for the majority of its operation, it's going to be running in one direction. And then if you look more at a discontinuous application, that's more where you get into servo type application where you're running back and forth. Even if you look at a robotics or a delta picker, each of those axes is really um, running forward, reverse, doing a lot of acceleration, deceleration, stop starting. And so it just is a way we really categorize our product portfolio. Um, Considering it a continuous or discontinuous. So today, we really have great news on our expansion of our discontinuous drive portfolio with these new drives, the Sinamics S200 and the Sinamics S210.
Excellent. I can't wait to learn about them.
So this is kind of a more of an overview of our discontinuous motion portfolio. And you and I think most of your viewers are probably going to be really familiar with our Sinamics S120 because this is our do-it-all, do-everything drive, single access, multi-access, extremely wide power range, uh, capability of regenerating back to the incoming line if we need to, along with the common DC bus. Yeah, it really doesn't care if we're running it in servo or vector or volts per hertz. It just does everything. It just has the capability of putting any type of technology in it or with it. Um, I mean, that's really why that's so successful of a product line with the Sinamics S120. While we have millions of them in operation today. Um, as we start looking at some of our other applications, or if you want to take a look at different types of machines and the discontinuous motion portfolios or markets that are out there, what we see is there is a large market in what we call the mid-range, and that mid-range. Um, with that one, it's typically a servo type of market, usually a little bit lower power range than we have um, with, when you look at a complete, continuous offering or a full offering like we have with S120. So this one in the mid range with the S210 is really focused on that mid range segment. And a lot of machines, I guess, we target those 1 to 10 axes. The sweet spot I always say for the S210 is really that 3 to 6 axes type of machine. And that has a lot of the performance capabilities of the S120. Also has capability of doing, if you want to call it common DC bus, for the smaller multi-access type applications. But again, it's more centered around a lot more easy to be able to implement So you don't have all that flexibility, but it fits in for just a wide range of those typical applications where you would use a servo drive on. And that one, that's a servo package. So, we have a set of motors. We expanded the set of motors that we have. So we have our standard motor, which we run with the S210, the 1FL2. We expanded this to the 1FL7 capability. So that just kind of takes all of our standard offerings that we have and expands that with a lot of additional offerings. And these can range anywhere from different type of paint color to different type of encoder, different type of speed ranges. And then we really rounded it out with also coming out with a stainless steel motor, 1F S2, S for stainless steel, which we use with the S210. So it's a servo package where we'll supply the motor, drive, and cable. And that's a one cable connection as well between the motor and the drive. So the S210, we've just updated that with the new generation. So it's a chipset update to the S210, bringing it up to this new generation with all the latest capabilities as well. And then when we get into the Sinamics S200, this is a standard servo market that, we haven't really participated in other than using some of our higher capability drives for a lot of these standard or basic servo applications. And these are usually single access applications that are out there. And, with them, they're usually more concerned of meeting a certain price point, looking at ease of implementation as well. And for a lot of these applications that we see in the standard servo package range, this is also a motor drive and cable set. And that's more typical of what they're looking for, to have a complete set and easy to implement that as well. This market is also a lot of the new markets that are coming in out there now with battery plants that are coming in, a lot of semiconductor, as well as some of your new technologies that you're seeing where somebody really has a machine and maybe they've been using steppers on it and they're really wanting to bring that up into more of a modern machine, get into a servo type application where they can run it a lot faster and have a lot more capabilities that they want as well. So this really puts us in a position where we have just a really formidable platform for our discontinuous motion portfolio.
It seems like you could do everything with the 120, the S120, and that goes all the way up to 3,000 kilowatts, right?
Yeah, so with the S120, I mean, we will cover pretty much all the voltage ranges with the low voltage range. So pretty much everything under 1,000 volt with the S120. And when we get into the larger frame sizes, more of the chassis frame sizes, we can parallel those. So we've done, some drive systems up, 5,000 horsepower and above actually with the
Wow.
S120. So yeah, it is truly the, does everything, runs any type of motor, can be configured anyhow, communicates with everything. It's just really a do it all type of drive.
Yeah, so it looks like with the introduction of the 200 and the 210, the S200 and 210, you now have products available that maybe the S120 was overkill for you. Your standalone servo and your smaller systems, like you said, what did you say, 3 to 6, 3 to 7 servo type systems with the S210?
Yeah, would there just be, somebody just needs to maybe add one axis where they're just gonna sit there and maybe they need to position it 90 degrees. They're gonna put one label on and 180 if they're gonna put another label on it.
Hmm.
They'll add a servo axis in there with the S200. But then you get a lot of the, if you want to call them more of the Delta picker, where it's more of a three-axis robotic type
Hmm. Hmm.
application. The S210 fits in really well with that. Yeah, I was just saying you kind of segue a little bit into the next slide I had, and that's really where if you take a look at the portfolio, really builds on each product line to the next. So you might have applications where the S200 is going to fulfill everything that you need to do, take care of for a simple application. Maybe you just need, you don't need safety, or you just need a STO hardwired into it. And then you get into more of the S210, where you can, do extended safety functions, and you can control those over ProfiSafe, over the industrial Ethernet. And then you get more into the S120, where you're really wanting to do a lot of specialty functions, or winder type applications. A lot of applications we use the S120 for as well might be hoisting, crane type applications. So yeah, it's kind of well, it is a portfolio that really builds on itself, and its um, capability of basically being able to standardize on the Sinamics S product range, really no matter what machine level you have. The other thing really wanted to mention here in our discussions today too is we have, if we look at the functionality on the left, the performance and drive functions on the left. What we see is a lot of functions that are, very standard to drive applications that are out there that we've had for years and years and decades as well. But when we take a look at this new generation that we're bringing out, and S200 and the S210 are some of the first drive lines that we've come out with this new generation. What we see is there's also a lot of additional requirements that we're starting to see now and in the future for drive systems as well. And if we take a look at that, what key requirements that we're really starting to see out there that, for the past years, they really haven't been, all of these really haven't been, standard requirements, but they're really coming into play. And we've really been able to capitalize on these with our new generation as well. And that has to do with safety and security for one. The drive safety integrated functionality, and expanding those functions, having a higher level of safety functions as well. And then security is another big one with everything happening and cybersecurity coming up. So having a new chipset actually where we have the security integrated into it, and whether we're, you know, wanting to hardenize um, the communication to the drive to make sure we have secure network capability, or to make sure that somebody can't go in there and just change parameters. You got to have rights to be able to change parameters. Also, consistency checks, checking your parameter settings in your firmware to make sure nothing's been manipulated. So that's a big thing that we're starting to see out there as a requirement. And then, of course, usability, with everyone struggling to get technical workers that can handle a lot of this more complex automation that's coming in out there. So having a lot of that plug and play type applications, or being able to do an easy selection with a complete servo axes and easily to integrate that in, the usability is just becoming more and more of a factor. And then, this is a little more of a buzzword, but it's really starting to think about this too when we talk about sustainability with the drive. And that sustainability really comes from energy efficiency on the one side. So being able to run the drive more efficiently, or run a more efficient motor like a synchronous reluctance motor, as well as being able to reduce your harmonics, being able to implement just solutions that are going to use less energy. But there's a whole aspect to this too, which really is the whole life cycle of the drive. So how the drive was built, and basically um, listing all the materials that are in your drive. And from that, what you'll see is a lot of times now products are coming out and they require an EPD, environmental protection declaration. So listing all the types of material that are in the drive, and also through the whole life cycle of it as well. So when this drive ends up, decade or two away, and it needs to be thrown out, how is that going to be recycled as well? So having that plan of how the product's going to be recycled is a big point going forward that we're going to see. And then, of course, digitalization, and that's really huge. From being able to do the digital twin, all the simulation capabilities that are now coming into play, and then the connectivity. Whether we're going back to an edge device to bring the information from the drive and motor back there, or whether we want to bring it up to the cloud and do all the data analytics. So for us, this new generation, there's a lot of if you want to call it key requirements that they've been designed for that'll really help us going forward. Next thing I wanted to do is just talk a little bit more about the two products that we have coming out, and that's the Sinamics S200. This is again our standard servo package. You see there, motor, drive, and cable. Um, in the smaller power range, it's two cables, but it's a hybrid cable, so it's actually comes together as one part, and it connects to the motor as one part with an easy connector there at the motor side. So the Cinemix S200, there's the 200, and then there's the 200 basic, and that's really just we've scaled down the functions even further. We've taken away the STO. So again, being able to implement this and to a very, if you want to call it, economic setting as well. And then two different types of interfaces that are available in the S200 range. And that's whether you're going to send it just a pulse train and follow the pulse train, or whether you're going to connect it to Profinet to a controller. And the power range of that for the 200-volt range, single and three phase, it brings us up to about 1 kilowatt. And then the 400-volt three phase range, that goes up to about 7 kilowatt. The motors, very flexible offering for our motors, with the inertia, low inertia, medium inertia, and high inertia. So this is a key thing when we take a look at a wide range of servo type applications out there requiring a specific inertia matching. And on the encoders, these encoders don't require any batteries. 17 or 21 bit, that can be a single turn or a multi-turn absolute as well. And IP ratings, the English protection ratings on the motor with the go up all the way up to an IP65. Flexibility on our cables too. We have Motion Connect is the name of our cables. We have a 350 and a 380. So if you were going to put them in a fixed location, um, you know, um, a wiring tray, then you'd use the 350. If they were in an application where the cables are going to be moving with the application, then we go to our cable that has the higher flex rating, and that's the 380. With the S200, we can go up to 30 meters length on that as well. And then for integrating these in, our selection tool allows easily to go in and configure, what you're going to need based on your requirements of the application, your load requirements, and then commissioning them with Star Drive, and we can bring this in the TIA portal. We could also use the web server to commission them as well. So if customer just doing a basic setup and he just wants to go on the web server, connect those up. Nice thing about the S200 is when the drive is connected up to the motor, it reads all the information from the motor. So, there's a lot less programming that has to be done as well. And then for simulation capabilities, it is modeled with the Drive Sim Basic for that. Key applications that we're looking into, we mentioned earlier, batteries really taken off. So a lot of the battery manufacturing, the semiconductor, packaging, as there's a wide range of different packaging type of machines that are out there, and many OEMs have different levels of their packaging. So this fits in really well with their entry level type of machines. Because woodworking and solar as well. Solar from the production of the solar to actually even positioning the solar as well. So we're starting to see a lot more applications in that standard servo package. And then moving on to the Sinamics S210. We also call it the S210 new because it has the new generation chipset in that. And this really moves us into more of the mid-range systems where you'll typically have more coordinated motion axes. For that, we have a single phase 230-volt line at the 750 watt, and then we have the three-phase line, which handles 200 through 400 class, and that one brings us all the way up to 7 kW. The three-phase units, those are the ones that you can do AC coupling and DC coupling as well. So if you have a typical discontinuous motion application where you might have a couple axes that are motoring and a couple axes that are generating, we can recover that regenerating power for the motoring axes. So again, helps it out to become really efficient. And of course, the S210 is extremely high performance. We have a current controller, 62.5 microseconds, really leading to a lot of the other capabilities that it has, along with Profinet isochronous real time. So extremely highly dynamic servo system with the S210 and integrates very easily as well into our somatic controllers like the 1500 PLCs. So we have the technology objects to easily control and coordinate the axes. And we also have the safety libraries, and that kind of brings us into the safety integrated functionality. And again, that really reduces engineering time, makes it really easy to integrate the safety integrated functionality as well between your fail-safe controller and the drive system as well. And basic and extended functionality that we can do with the S210. So we can get up into the motion monitoring, the brake monitoring, all of that higher level coordinated safety functions can be integrated with the S210. One cable connection for it, so very easy to install. It already has an integrated EMC filter and braking resistor. Tuning in, it's just a one-button tuning. So again, this really allows the OEM to easily get the solution in and get it commissioned with the S210. That's why it's become real popular and a quickly expanding customer base. With the S210, typically you'll see it in machines from 1 to 10 axes. I always say, it really has a sweet spot from about 3 to 6 axes type of machines. So a lot more packaging, printing, converting plastics, all the moving and handling type applications, and then just general machine building or general robotic kinematic type applications as well. And those are featured as well in our somatic controllers. So with the easy integration of the S210, those solutions just seem to be ones that can be engineered very quickly and at a level that's highly integrated and highly functional. So that was the overview I had for you, Shawn. Like I said, really think that this is going to expand our footprint out there, which we see in this discontinuous motion realm, and a lot of customers as well that may have looked at some of our product lines or product line like the Sinamics S120, and as you mentioned earlier, they might have said, "Hey, this is a little bit of overkill for what I'm doing." So this really, I think, fits into a wider range of customers that we'll see with our Sinamics S-type drives.
All right. Well, I got questions for you, Craig.
Oh, great.
Can you go back to the S200 standalone slide?
Yes.
Okay, so everything on this slide makes a lot of sense to me. Um, my question for you is, so this is just a drive, so I need to connect this to a controller, correct?
If you just wanted to connect up some I/O to it, because it has built-in positioning inside the drive.
Okay,
So if you just wanted to send it some digital commands, say run and run to 90 degrees, now run to 180 degrees, and
okay,
doing some basic applications like that. It has the capabilities just in itself to do positioning.
okay.
Then you get into, if you want to call it, I guess the next scenario where you'll have a motion controller. This may be a very generic motion controller that's just sending out a series of pulses. So it's usually pulse and direction, sends out uh, pulses, and you just follow those pulses and one direction command for whether you're running forward or reverse. And then the higher level would really then be you'd move up to the controller that would have Profinet, and you could do that direct connection from that controller to the drive.
Now, if I was using Profinet, would I have to have is there a minimum CPU that I would have to utilize this S200?
As long as it's a controller that talks Profinet and supports one of our telegrams that we have for the S200, really doesn't matter what or whose controller that is.
So where I'm going with this is because this is a standalone servo drive, right? And servo.
Correct.
I'm wondering if on a small machine, if an OEM could use an S7 1200, would that be possible?
It would be possible.
Okay.
So depending on, what our level of control is, I mean, of course, if we just want to do speed regulation, that'd be very simple. If we wanted to do some positioning, if it's just point-to-point positioning, you kind of have the option whether you would want to do it in your controller or whether you want to do it in the drive. But then we move up to more coordinated type systems where we have two or three axes and we're trying to coordinate the motion. That's when we really need to look what type of controller we're using.
Okay, great. So if you go to the next slide on the S210, right? I'm seeing that it supports Profinet IRT, high speed, right?
That's
And
correct.
typically, when you're using one of these systems, it looks like you're going to probably be in the S7 1500. And so my question is, is there a specific model? Like, can I just use a plain Jane S7 1500, or do I need one of the special models? Can you talk about that? What would be the advantages there?
Yeah. So again, even with the S210, it not wouldn't necessarily have to be an S7 1500 class PLC.
Mhm.
But for the majority of applications that this is being implemented on, we are using a 1500 class PLC. And this is going to be the technology version of the 1500. And most likely it's going to be the F failsafe version. So with that, it gives us a lot of capabilities. When I talked about a kinematic type function, like three axes that were coordinating, each arm to coordinate the
Mhm.
motion of, a delta picker, all that at this point can now be done in the 1500 with the technology objects. So this is kind of like a canned solution for it. It makes it very easy to engineer. You don't have to spend a lot of engineering time doing this. So you use the technology object that can do the coordinated motion. And for most applications, you're going to want safety as well. So with the F version of it, we can now do all of our fail safe. So whether that be safe limited speed, safe direction, all of our safe stopping, safe brake, all that can be done in that type of a solution. But very scalable, very flexible how we do it. Like I said, a lot of people really like to take advantage of the full capabilities when you get into the kinematic or robotic type applications.
So for those who may not be familiar with the S7 1500, you have your standard CPUs, and then you have your technology CPUs, which I always, maybe incorrectly, but I always link those to motion control, right? To those advanced features you're talking about. And then you also have the fail-safe series, which is a safety PLC version. And then you have the technology with fail-safe as well. So there are a lot of options in that product line. And it just sounds like it makes sense because you have ProfiSafe built into these drives. Am I correct? These have ProfiSafe built in, right?
You are correct.
So it makes sense to use the fail-safe technology CPU because you not only get those advanced motion capabilities, right? You also get the ProfiSafe capabilities to do all of the safe speed and other things you were just talking about. So I get and that's kind of where I was going with that is like what's the typical CPU you're seeing used with these S210s and that makes a lot of sense to me.
Yeah, and that platform's really scalable too. So, I mean, if we wanted to do, you know, didn't want to use ProfiSafe and we just wanted to speed control it, we could use just a bare bones version. As we move up all the way to, if you want to call it the higher level, the more complex level, where we're doing a lot of coordination between axes and we're doing a lot of safety as well. That's when we get into the higher levels. But the nice thing about those is it's the same software which we use. We program it all from the TIA portal, and it's the same look and feel, whether you're looking for a real basic type application or whether you're looking for a very complex motion type application. And with our drive series as well that we went through, if you look at our discontinuous motion offering that we have for our drives, it fits into that scalability as well.
Yeah, and just for the audience who are listening, we actually have an episode just talking about the technology CPUs. with one of Craig's colleagues. So it's been a while, so I don't remember all the details from it. But if you wanted to get up to speed on those technology CPUs and those advanced features and functions, check out that previous episode of the Automation Podcast. Um, and I probably should have watched that before today's show. But in
Yeah,
any
that's.
case, go ahead.
I was gonna say, yeah. My colleague Kevin Wu, he's lot more of an expert on that than me. So, but hopefully I was able to clarify that as well.
Yeah, and Kevin did a great job in that episode. And so, for anybody who wants to learn more on that side of it, definitely check out that previous episode of the podcast. And Craig, you've answered all my questions. Was there anything else you wanted to talk to us about?
Oh, Sean, just real excited to talk to you about more of our capabilities from automation to our drive offering as well. Like I said, we have a lot of new stuff coming out, so we look forward to talking with you continuously on this.
Excellent. Yeah, I love to get up to speed on your product lines. This is just one part of a very broad portfolio you guys have, and it's good to now feel like comfortable with what the S200 and S210 is, because of course we saw the press releases come out on them, but never had a chance to sit down and look at them. So, Craig, I just really want to thank you for coming on the show and bringing us up to speed.
All right, thanks, Sean.
Well, I hope you enjoyed that episode. I want to thank Craig for taking time out of his busy schedule to come on the show and bring us up to speed on the S200 and S210 servo drives. Now, if you did enjoy this episode, please consider giving us a like, a sub, and a share. That is the fuel that keeps this show on the air. Also, if you want to get in touch with me, ask me a question, or just follow me, you can do so over at automation.locals.com. And of course, you'll find all of my training courses over at theautomationschool.com. With that, I want to wish you all an awesome week, and I want to encourage you to stay courageous, stay fearless, and until next time, my friends, peace.